Hello, fifth grade math students. This is our video introduction for chapter 13, looking at different shapes and specifically focusing on triangles and four-sided figures. You do not have any homework tonight, but you need to watch this entire video, including going through the quick check at the end. So make sure your book is open. We are on page 183, excuse me. As a reminder, you can always pause the video if you need minutes to get your book out. Now your book has descriptions for each of these 6 shapes. I'm going to talk through all of them individually, and then we'll begin the quick check. A triangle. Our description is a triangle has 3 sides and 3 angles. Remembering that angles are where 2 sides meet, or 2 line segments meet. So there's 3 angles and 3 sides. Something that you know, and remember all this is review. A parallelogram. A parallelogram is a 4-sided figure in which the opposite sides are parallel. So if I look at these opposite sides, I can say they are parallel. Do you remember what parallel means? Parallel are 2 lines that will never meet. So if I extended this line on infinitely in this direction and then this one as well, those are going to continue in this way and never meet. Where if I drew some lines like this, these 2 don't meet, but eventually if I drew a dotted line, they're going to intersect. But parallel lines will never meet, and in a parallelogram, all 4 sides are made up of opposites that will never meet. That's the only actual requirement for a parallelogram. Now a rectangle is a particular parallelogram. It's a parallelogram that also has 4 right angles, and you can see that because we have little squares in each of the corners of this shape. Is this also a parallelogram? Will the sides that are opposite never meet? Yes, if I kept on drawing those lines, they would never intersect. So a rectangle is a particular kind of parallelogram. The next shape up here is the rhombus. A rhombus is a parallelogram with all sides of equal length. So like the parallelogram, these sides will never meet, but not every parallelogram have sides that are all equal. And in a rhombus, they are all equal. I actually think of it a little bit like a square that I've tilted over. So I've shifted it so all the sides are still equal to each other, but they're not right angles like they'd be in a rectangle or a square. So the unique thing about a rhombus is that each side is equal. Speaking of squares, squares are maybe the most specific shape on here. Squares are a rectangle with all sides of equal length. So it has equal length like a rhombus. It has right angles like a rectangle does. And all 4 of these are parallelograms because they all have 2 pairs of parallel lines. So these 4 are all somewhat related, but they're all unique. So to touch on again what makes them each unique from each other, a parallelogram just needs to have 2 sets of parallel lines. The rectangle also has 2 sets of parallel lines, but it also needs to have 4 right angles. In a rhombus, all 4 sides of this parallelogram need to be equal to each other. And a square needs to have 4 equal sides, 4 sides that are parallel to each other, and 4 right angles. So again, the most specific. Now I think of all these, a trapezoid is maybe the oddest one. A trapezoid is something that has 4 sides in which only one pair of opposite sides is parallel. So which pair here is parallel? These 2. They will never touch if I keep drawing this line. These 2, if I drew it, they're going to meet somewhere down here, right? So those 2 are not parallel. Now this is important. A common mistake with trapezoids is people think that these 2 have to be equal to each other. That's not necessarily true. If I drew, let me do a different color. If I drew a shape like that, that's actually a trapezoid because I've got 2 sides that are parallel to each other. And even though these are different lengths, the only requirement for a trapezoid is that 2 sides are parallel. All right, now let's move down to this next section. Excuse me. Finding measures of angles on a line. These 3 are angles on a line. Hopefully remember this because you just took a quiz on it yesterday. What does the sum of these 3 angles have to be? Well, I don't know specifically what any of them are independently, but all three of them together are angles on a line. Therefore, they must be 180 degrees total. The other thing to make sure that we remember is how to show equalities but also inequalities. So here's three different equations they've given us, all considering x plus 15 and 35. What's the relationship between x plus 15 and 35 if x was 10? Well, 10 plus 15 is 25. Is 25 equal to 35? No, 35 is larger. So how should I draw that inequality? Like that, to say 35 is greater than x plus 15. Well, what if x was 25? 25 plus 15 is 40. Is 40 is not equal to 35. And this time, this value is larger. So I have to draw the inequality going towards the larger number, which again is 40. If x equals 20, 20 plus 15 is 35. Now we finally have one that are equal. So remember how to draw those inequalities and make sure that they're facing the right way. All right, now we're on to the quick check. They've asked for us here to identify what we would label these three different sides. Remember that I would write the two different points that make up the line segment. I draw a line over them to signify that it's a line that they make together. So PQ is one of them. What are the other two? If you were thinking QR and RP, I was thinking the same thing. Those are the three different sides. And what about the angles? Remember, there's multiple ways to write the angles. Do you remember the simplest way? If I just write down the letter, that's easily the simplest, right? You can know right away that this is the angle that I'm talking about. But as we learned in our last chapter, sometimes that's not specific enough. So how would you be more specific about the angle? Thinking specifically about that one. Remember how you use all three letters, the two lines that make up the point, and then the middle letter is where the angle actually is. So PQ, where the angle is to R. So PQR, QRP, and QPR. Remember, I could also switch the letters. The important thing is that letter that is in the middle. That's where the angle actually is. All right, here's some fill in the blank for us to work through. The opposite blank of a parallelogram are parallel. What are the opposite things that are parallel in a parallelogram? The answer to that one is sides. Ooh, I may not have room to fill in the blank for all of these. All right, a rectangle has blank sides of equal length. How many of the different sides have equal length? The answer is there's this kind of a tricky one. A rectangle has two pairs. Because remember, in a rectangle, these two are equal to each other, and these two are equal to each other. It's not like a square where all four are equal to each other, but it has two pairs of sides that have equal lengths. So get this one. The measure of each angle of a rectangle is how many degrees? What kind of angle is each angle in a rectangle? It's a right angle. So how many degrees is that? 90. A parallelogram with four right angles is think about a parallelogram that has four sides that have four angles that are right. That is a rectangle. The four sides of a square are of blank length. Equal for that one. All four sides have to be equal to each other to make it a square. Each angle of a square is a what kind of angle? That'd be a right angle, just like the rectangle. A rectangle with four sides of equal length is a square. Remember, a square is just like a rectangle, except all of the four sides are equal to each other. The four sides of a rhombus are of blank length. Are they different or the same? They're the same. Just like a square, except a square has to have right angles, which a rhombus does not. And then finally, a trapezoid has only one pair of opposite sides that is probably equal or parallel. Which one do you think? If you're thinking parallel, you are correct. Remember, a trapezoid does not have to have any sides that are of equal length, and it often actually does not. All right, just a couple more for us to look at. In this one, they've drawn, they told us that AB is a line. Which two angles have to add up to be 180? You've got two pairs. I'm thinking probably angles on a line. So this one right here, angle A, this should be O, angle AOC plus COB, COB, and then these two, AOD and DOB. Because remember, those are angles on a line, which means that they have to add up to be 180. Are there any vertical angles? A little bonus question in this. There are not, because we do not have two intersecting lines. So I don't know if any of these are equal to each other. So I can't assume that. All right, and then finally, there's a little mess up there, so you can ignore that. Let's do some inequalities or equalities. If x equals 5, x minus 2 is greater than, less than, or equal to 10. See, 5 minus 2 is 3. That's less than. So 10 is a greater number. If x equals 20, x plus 5 and 15. 20 plus 5 is 25. That's greater than 15. And if x equals 30, x plus 10, greater than, less than, or equal to 40. 30 plus 10 is 40. 40 is equal to 40. Okay? All right, again, you actually don't have any math homework tonight, but make sure you're really familiar with all of these terms, especially thinking about these different figures. They're going to come up a lot in our next chapter. So if you have any questions, make sure that you get ready to ask me those. And then tomorrow we'll pick up with lesson 13.1. Thank you.